Hello, everyone. Hello. Welcome to Drasi office hours. Uh,
Hello.
I see some familiar faces here. Hello.
Hello,
Hi
good
there.
evening, good morning. Okay.
We also have yeah, go ahead, please, Hanok. Can you hear us, Hanok? Uh, Let me just reach out to them in the chat. And we can also give a couple minutes for other folks to join if somebody else wants to join. All right, I guess let's get started. So, okay, there's okay. Hello, hi, Hanok. Are you able to hear us? Would you like to unmute and yeah?
Yes, I can hear you guys now. Yeah.
Okay, great. Yeah, glad
Okay.
to have you here. Thank you for joining Drasi Office Hours, everyone.
Happy to be.
All right, so we have one new person, so I'll try to go over some of the same things that I went over yesterday. But yeah, feel free to stop at any time. Just ask any questions. You can come on, unmute, and then ask questions, or you can also raise your hands. Totally up to you. Yeah, so let's get started. So today I'm going to cover. All right, so yeah, so today I'm going to cover a few things. Just go quickly over what is Drasi, maybe talk a bit about the team behind Drasi and the project history and the various form factors in which you can use Drasi. Give maybe a brief tour over the repository tour, like what are the different repos within the project and how it all fits together. And then also talk a bit about the documents, the tutorials, and what's next. And then we can also talk about how do we get involved, and then what are the best practices. And if you have any questions, we can cover those while we are going through these slides, and we can also take some deeper discussions at the end. So, all right. So, what is Drasi and why does it exist, right? So, let's try to answer that question first. So, like in modern systems, we have data that is sitting in multiple different systems, right? And these different systems are also heterogeneous in the sense that data might be stored in different form factors there. So, for example, you may have relational databases, non-relational databases, which could also be of object type, let's say, or document type, right? So, you may have document databases like MongoDB, you may have relational databases like Postgres, you may even have graph databases like Cosmos DB or others like Neo4j, etc. And you may also have other systems, let's say config stores or even Kubernetes cluster that you may want to monitor. Now, all this data is constantly changing, and you need something that needs to detect the relevant changes and react to it. And there are several scenarios for that, right, in real world. Now, how do we detect meaningful changes and react to them today, right? So there's three broad options. So first is simple, which is just polling, and that's kind of standard, right? Where you simply run your queries. You basically query your system on a set schedule, and then you get whatever has changed. You try to identify whether the meaningful conditions have been met, and if so, you just try to react to it. If not, then you just poll again on your next iteration of the schedule. Now that is pretty straightforward, but it is kind of wasteful, right? Because uh, let's say you are querying your systems 10 times every 1 hour, right? But maybe your data or your system has not changed in that interval. So that means that you're basically putting an extra load on your systems by querying those extra 9 times. Maybe only one time the data has changed. On the other extreme of it is, let's say you increase the polling interval because you think that the data might not be changing as frequently. In that case, whenever a change happens, the length of the polling interval will define the latency of your reaction, right? So let's say at 11 or let's say at 1 p.m., the data has changed, but your polling frequency is every 3 hours. So in the worst case, you may be reacting to that change after 3 hours, right? Almost after 3 hours. So that's about polling. The other standard approach that is commonly used is also event streaming or stream processing, where you might dump all of the events into a message broker like Kafka or other kind of message brokers. And then maybe you write a stream processor on top of that, right? So you can use Kafka streams or something like Flink. Let me just give me 1 second. There's somebody pinging on Discord. They want to join. All right. So yeah. So this is the second approach, right? So the event streaming or stream processing approach, where you do get low latency, but then you will have to write this stateful stream processing logic yourself. Now, this involves like doing state management, watermark tracking, and all of that manually through code. And then, of course, with AI, you can now write code more easily. But then it's not just about writing code; you also have to maintain that. So that can get quite complex. And then you also, of course, have to run all of these clusters, right? So the operational load is also there of running Flink and running Kafka, etc. So Drasi has come up with this new change-driven approach, which is the third one listed here on the slide, um, where you just need to declare whatever data set matters to you. And this data set could be derived from multiple different underlying sources. And you basically declare that using a graph query. And then whenever your result set of that query changes, you basically are able to react to that. Like we have another person join the call. Hello, hey.
Hi. Hi.
Yeah, thank you for joining the Drasi office hours. We are just doing a quick refresher of what is the problem that Drasi is trying to solve, and then we'll just go over some of the common things. Let me just rewind that. So this is like the agenda for today. And by the way, this session will be recorded and will be posted to the YouTube channel. So let me know if any of you have any concerns. So yeah, let's continue. So we were just talking about like the problem that Drasi is trying to solve, where data is spread across multiple systems, and you may want to detect changes to that and then react to that in near real time. So for which you could have multiple different approaches. Either you do polling or event streams, or you use Drasi's declarative change-driven approach. So that's the core problem that we have set out to solve. And we think that Drasi is able to simplify change-driven architectures using three core concepts, right? So the first one is called sources, which is something like you can think of it like input connectors, right? So this is what allows Drasi to connect to your existing data systems. So with Drasi, we don't want people to get involved into a data migration project and then migrate all of your data into a central place and all of that. That's kind of complex, and people don't want to do that for data sovereignty and all of those other issues. So what Drasi allows you to do is just connect your data, just point Drasi to your existing system using sources, right? So these sources can allow Drasi to connect to databases, APIs, Kubernetes, a lot of different systems which may be storing data in different forms. Now, the other responsibility of sources, apart from connecting to these external systems, is to translate that data into a property graph model so that Drasi can then run graph queries on it. And that is the key, right? So basically, what happens is all of these sources may be storing their data in different forms like relational, object store, etc. And then Drasi is basically translating that into a property graph model. So basically, it's translating, for example, relational tables where each row may get translated into a node of the graph. So you need to basically translate that into nodes and edges. Now, once that graph exists, you can then also tell Drasi how to connect data coming in from different sources, right? So how do you connect entities that are basically represented in the Postgres database, for example, to the entities that are maybe existing in the Kubernetes cluster? So that kind of join becomes possible within a graph. And once you have that kind of graphical representation, then Drasi allows you to write queries, and that brings me to the second concept, which is continuous queries. Now, you may think from the name that the queries are kind of running constantly or continuously um, on your existing systems, but that's not the case. What Drasi does is it basically monitors all of your existing systems through their change feeds if available, or it can also resort to other techniques based depending on the system. So that logic is effectively coded in the source itself. So basically, continuous queries can be written in Cypher or GQL, which is the new ISO standard for graph queries. And these give you the illusion that they're running continuously, but effectively they are maintaining a live result set that keeps getting updated based on whatever changes are happening in your data source. And then these queries can, of course, span multiple sources. And once the result sets update, the queries will just emit three kind of signals: whether a new result got added, an existing result row got updated, or a previously existing result row got removed, right? Now, what do we do with this kind of result diff, right? We know that some of the query results are changing, but what can we do with that? Well, that brings me to the third core concept, which is reactions, and that allows Drasi to take actions in external systems. Now, you can think of this as output connectors for Drasi, right? You can basically configure like a webhook. You can push via server-side events. You can write to a database, do some logging, maybe send a Slack message, etc. That totally depends on your scenario. And this enables basically we believe that Drasi enables simplified change-driven architectures, and two patterns where this manifests, just as an example, could be derived views or real-time actions, right? So because Drasi reactions can take actions in external systems, one of the type of external actions could be to just update a materialized view, right? So think of a scenario where you may have a live dashboard. Just if you have run through one of the tutorials, for example, in the curbside pickup tutorial, we have the live dashboard which shows which cars have arrived at the curbside and which orders are ready, right? So that's kind of like a derived view that is getting data from multiple different sources. A, from the retails database, B, from the vehicle database, right? So that basically is joining data from multiple sources and basically showing that in a live dashboard. So that is basically another form of a derived view. Another example of a derived view could also be a vector store that could be used for RAG. And we have the KubeCon talk where we showcase that example here. Now, maintaining derived views is just one use case where Drasi could be used. Another use case could be just taking real-time actions, right? Responding to changes in real time. Now, this could be, for example, let's say you connect Drasi to a Kubernetes cluster. So then Drasi starts monitoring whatever pods or containers are getting deployed on your cluster. And then on the same Drasi instance, you also connect it to your vulnerability database. So that basically means that Drasi will also watch the list of vulnerable container images that are constantly updated by your security team, and then do a live join on those two, right? Now, based on that, what can happen is whenever a new container or a new pod gets deployed on your Kubernetes cluster with a vulnerable image, Drasi can basically act on that. It could either trigger or launch a new workflow, or it could just simply send a Slack message tagging the appropriate service owner to basically fix that issue. All right, so these are the two patterns. And if you need to take a deeper look at that, you can just go back to the KubeCon talk where I've explained those two in more detail. But the whole point of this is that Drasi simplifies things for you. So you don't need to worry about writing stream processing logic or doing polling. Just write a graph query and then point at your sources, configure your reaction, and Drasi handles everything else. All right, so where does Drasi come from and how did we get here? So Drasi was started within the Azure Incubations team. So this is part of the office of the CTO of Azure at Microsoft. And we are a pretty small team. So we are just 5 people right now. And those are the core maintainers at the moment. But of course, we are looking to grow the community and get more new maintainers for the project. So this is also the same place where Dapper project was started. And then it went on to graduate from CNCF. But yeah, even though the project is initially backed by Microsoft, but it is fully open source right now with Apache 2.0 license and is also part of CNCF. So there's nothing proprietary about it. And a bit of a timeline. So we launched as an open source project all the way back in 2024, and then we got accepted into CNCF at the sandbox maturity level in January of 25. We were able to get our first KubeCon talk in November of 25. And early in 2026, we also launched two new form factors of Drasi, making a total of three. And this year, basically, we are also trying to grow the community, participating in different programs like LFX mentorship program, and also Google Summer of Code. All right. So yeah, let me just talk a bit about the three deployment modes that are possible today with Drasi. So the first one is Drasi for Kubernetes, which basically is based on different microservices that are running on top of Kubernetes cluster. And this comes with a CLI, like a command line tool. And basically what you can do is you can write different YAML manifest files that define the sources, queries, and reactions. And this is also, you can try this out in our various tutorials that are available on our website. This is for basically the production kind of scenarios where you want scale, you want individual scaling across sources, reactions, and all of that. So for that, we built this platform, and this is the main offering that we had been building so far until late 2025. The other two offerings are something entirely new, which we have started building starting of this year, which is called Drasi Server and Drasi Library. So what we did was like because a lot of people wanted to use Drasi outside of Kubernetes, so we took the logic of sources, queries, and reactions as a core concept and brought it inside the core library itself, right? So that's the Drasi library, which is effectively just an embeddable Rust library. So all you need to do is, if you're building a Rust application, just to cargo add Drasi lib, and you get to use all of the Drasi concepts within your own existing process. Now, some of the people might not want to write a Rust application. So for them, we also brought up this standalone binary, which is also packaged as a Docker image. And then you can run it wherever you want. It could be like a sidecar. It could be running on just as a process on your laptop, or maybe on a Azure VM or some kind of cloud VM, AWS or whatever. So basically, it provides all of the capabilities that Drasi lib does inside a single process. And this allows you to also do YAML-based configs, and then also allows you to use a REST API to dynamically start, stop queries, or start or stop sources or reactions at runtime. The key point to note here is that the same core engine powers all three deployment modes. So your graph queries would effectively remain the same. All right. So which mode should you use, right? So if you're just using Drasi to prototype things or explore different queries, you should probably look at Drasi Server because it's easier to run as a standalone process. You can just say Drasi Server and on your terminal, and it'll basically launch based on the YAML config in your directory. You can just point it to the YAML config, and you can quickly start it, stop it, look at the logs. All of them are in a single place, so that makes debugging things easier. Once you have tested out with some mock data or even real data, you can iterate on your queries and decide that these are the sources and reactions you want to go with. And that's where you can move on to the Kubernetes platform if you need more scalable solution, or you can also continue with server or library, depending on your use case. So are there any questions so far? I'm trying to like rush through a lot of concepts because there's a few people who have already attended, but there's some new people as well. So please feel free to raise your hand or unmute your mic and let me know if you have any questions. Okay, so I'll keep continuing then. So let's talk briefly about the different repositories in our project. Okay, so the first one is called Drasi Core, and this one lives inside the Drasi project organization at GitHub. And within that, the repo is also called Drasi Core, and within that, there's a folder called Core. Now, this is the main differential engine that powers Drasi across all these different modes, right? So this has a bunch of different things like the query builder. This also supports the continuous queries, the elements, the element index, the source changes, etc. Also has all of the core functions of Drasi that we have also introduced uh, apart from the standard Cipher or GQL, right? So we also have some of the custom functions like true later, true until, which basically allows Drasi to watch when conditions don't happen for a certain period of time. So yeah, so I think this is the main core engine, which only understands source change events and then only emits result diffs, right? So there's no understanding of the individual sources. So there's no plugin code for sources or reactions. It's just the main query engine, and it can be run anywhere, or it's just a simple Rust library. So the second one is Drasi lib. So this is the embeddable runtime that I was talking about earlier, right? So this is allowing Drasi to, this is allows you to use Drasi within your own simple Rust process. Now, this also got added into the same exact repos that I discussed earlier. So let's say you look at Drasi project organization and the Drasi core repo inside that. Now, within that, if you go into the lib folder, that's where you'll find out the embeddable runtime. Now, what does it add over the raw Drasi core, right? So basically, it adds a bunch of different stuff. It adds the plugin architecture, adds some of the bootstrap providers, adds sources, reactions, and event routing, like how do the events flow from sources all the way to the query processor, and then from the query processor to the reaction themselves. So that's what Drasi lib adds, and we have published this to the crates.io. So all you need to do is run this cargo add Drasi lib command, and then the library becomes available to you in your own Rust code. And then you can just do something like this, right? So you can basically use the builder pattern, say Drasi lib builder with source. Let's say you are using HTTP source, define your query and use your reaction, and then just call build. And thereafter, you can basically write your own hello world application and then use Drasi concepts within that. Now, there's something about like the plugin ecosystem that is usable within Drasi lib. So you have like a bunch of different sources and a bunch of different reactions and also a bunch of different bootstrappers and index backends, right? So all of these live inside the core slash components, which are then shared by both Drasi lib and Drasi server, which I'll talk about next. But we have all these inside the Drasi core repo. Now, this is the Drasi server repo, which also lives inside the Drasi project organization. And this is just a thin wrapper around Drasi library, right? So what it provides you with is the ability to run Drasi library as a single standalone process, which you could run wherever you want. Now, this, what does it add, right? So it basically adds a few more capabilities on top of the Drasi library. Because in library, you have your own code that can basically add, remove, start, stop sources, reactions, etc. But when the process is already running, how do you control it, right? So you have one way, which is static YAML configs. So if you've already decided whatever sources or queries you want to run, just write a YAML file and then point your CLI to it, and then just run the Drasi server. Or once it is running, you can also control it at runtime using the REST API. So it has some of the other advanced capabilities as well, which you can take a look. And this is how the YAML config for the server looks like, right? So basically, you just write a single YAML file, tell it about the sources you want to use. For example, here I'm using the Postgres source, give it the connection string, some of the tables that you want to monitor, and then write your graph query like this, and then finally configure your reactions that look like this. And then once you have done that, you can just run the Drasi server binary pointing this to this particular YAML. And we have some of the getting started tutorials on our website, which you can take a look at. Now, this is the final one. This is the Drasi for Kubernetes repository. And for legacy reasons, it's called Drasi platform. So this is the kind of like a polyglot microservices that can be run on Kubernetes. So it has like a Go-based CLI, a Rust-based control plane, And that's the core project. But then you, of course, have sources and reactions which run as independent pods on your Kubernetes cluster, right? Now, these sources and reactions can be written in multiple different languages. So we have SDKs available for extended the sources and reactions. For example, you can build new sources using .NET, you can build those using Java, Rust, etc. And the reactions can also be built using .NET, JavaScript, Python. And you can always, of course, build new SDKs for different languages. Because the earlier form factors like the server and the library are completely in Rust, so whatever new sources and reactions you want to add to server or library need to be in Rust. But because Kubernetes allows us to run sources and reactions as independent microservices or independent pods, they can be written in any language, right? So right now we have support for these, but of course we can also add SDKs for other newer languages as well. And why did I say for legacy reasons? That I did not mean to imply that Drasi platform is legacy. It's just that we started off with Drasi platform at first, and this exists since almost our launch, which is in October of 2024, and maybe before that. But the other two new form factors or the other repos are much newer, and the team is focused on bringing them up to parity with the Kubernetes platform. But yeah, so this is still going to stay and it's not going away. So Drasi platform is where you can basically look at if you want to run things at scale. And if you want like a much broader set of sources and reactions, which you can see here, we have like more than 7 sources and more than 14 reactions. Any questions so far for the repos, or we can move ahead? Okay, so no questions so far.
Till now, no doubt.
Sorry, can you go ahead?
I'm just telling you till now, I don't have any kind of doubt. That's
Okay, okay, great. Thank you. So yeah, so these are the broad repos, and then we also have a couple of other repos. Let me just point to that on GitHub. So for example, this is the learning repo, and whenever you run one of our tutorials, this is where it comes from. So this is the repo that has all of our tutorial examples. If you run any of them from our website, so you're basically running code from this repo. And we also have another repo called Docs, which hosts all of the documentation for our website, right? So whenever you log into Drasi.io, you are looking at this website, but it's essentially driven by all of the code here. So if you want to make any doc changes, you can follow the uh, guidelines here. This is the documentation for making changes. And of course, you can use GitHub code spaces as well if you want to do things inside your browser, or you can of course use the VS Code dev containers if you want to do things locally. But yeah, so these are the main repos for Drasi right now on GitHub. And then this is something that I talked a bit about earlier, but effectively the Drasi core engine is the core differential engine that powers the Delta streaming engine, which powers the continuous queries. And then you have the Drasi lib runtime. And both of these, alongside the components, live inside the Drasi core repo. And then you have the Drasi platform repo, which uses the Drasi core engine as a Git submodule. But the server binary takes a direct dependency on the entire Drasi lib runtime. And of course, you can also use your own application, which can take a dependency on the different Rust scripts that we publish from the Drasi core repo. Okay, so what are the like documentation and tutorials available? Well, if you go to the Drasi.io website, we have like a bunch of different tutorials there for, especially for Kubernetes, which we have like a lot of tutorials there. So I'd strongly recommend starting with the getting started example. So if you go to the website, go to Drasi for Kubernetes and try out the getting started example. And this would give you like a feel of how Drasi works. And then you can go to the tutorials website and look at, let's say, the building comfort. The curbside pickup especially gives you like the contrast with traditional approaches. So we talk about like what are the existing approaches like polling and stream processing, and that gives you like a real feel of like how complicated things can get if you don't use Drasi. And then it also gives you the Drasi-based approach as well. And then you can, of course, follow this tutorial in different modes. You can use it, you can run it inside your browser without installing anything, just using free GitHub Codespace credits. If you run out of those credits, you can, of course, download VS Code, and you'll get exactly the same experience that you get within your browser. Just install the dev containers extension, and you'd be good to go. And if you don't want to do either of those two, you can, of course, do it locally, but you'll need to do a bunch of setup, and we have the steps listed for that. So these are some of the tutorials. A curious one is also Drasi for Dapper. So this also references one of the community calls for Dapper community, where we presented Drasi itself. That was last year. And this kind of showcases how Drasi can be useful for Dapper users, right? So what is Dapper? Dapper is another CNCF project for building microservices on top of Kubernetes, right? So it gives you like a lot of reusable components for building microservices like state store, service invocation, etc. And then we have provided some of the reactions here within Drasi that help Dapper users. So you can go through this tutorial to learn about that as well. So yeah, that's some of the documentation. And of course, you can also do, if you are comfortable with Rust, you can also run through the Drasi lib quick start on the website. And of course, you can also try a Drasi server. So these are the other two form factors. You can try this getting started example, or you can try the server version as well. Okay, so let's talk about what's coming up next. So right now the team is focused on bringing up the new form factors, the server and the core, up to speed with whatever offerings we have in the Kubernetes version. So it looks like the platform already has 15 plus connectors, but the server and library have 6 each today. So we're trying to cover that gap. And then we are also bringing the vector store reaction to the new modes. We are also trying to build capabilities for persistent indexes and faster recovery on the new formats. This already exists in the platform one. And I'd like to highlight that we are a community-driven roadmap. So whatever the community comes up with, so let's say there's a need for some new sources or reactions and people file issues on GitHub, depending on their, like if they have a real need. So we'll try to prioritize that. So the GitHub issues and contributions is what shapes the project. So yeah, how do we get involved? Try to find some good first issues on GitHub and follow the tutorials on Drasi.io. You can take a look at the Rust toolchain, take a look at Git submodules. So the pattern that we follow for making contributions to Drasi is fork-based contributions. So what I'd recommend is go to any of the repos. So let's say go to the Drasi project, and let's say you're working on the platform, go here, then you can effectively fork this repo. That'll basically give a copy of this repo inside your own GitHub account, and then make changes to your own fork. And then once you're done, you can create PRs from that, right? So let's say we can go to my account here. So I have also forked the Drasi platform repo. So you can see this is the Drasi platform repo under my own account. And I can make some commits here. Once I've made some commit on my branch, I can click on contribute and I'll basically see a button here to create a pull request. So we'd recommend creating pull requests using a fork-based approach. And the other thing I'd recommend is like whenever you are making commits to Drasi project, one of the requirement is DCO sign-off, for which all you need to do is if you have set up Git properly on your machine, you can basically use git commit as usual. Just remember to use the -s or -s flag here alongside your message. Let's say this is my commit, but this S flag is what will add a sign-off message to your commits, and that'll make sure that your pull requests pass all of the checks. So yeah, that's what we have right now. And then you can go to our different links here. Like you can go to drasi.io for our website. You can go to our Discord channel. And of course, you can look at our code on GitHub and make some contributions. Yeah, that's all I had for today. And we can take some time for any questions you may have, or we can dive deeper into any of the tutorials or any issues you may have run into. So anything is fair game. You can ask any questions. You can ask questions about Drasi, Dapper, whatever you want.
Hi,
Um,
Aman. I had a question regarding clarification of project. Can I ask?
sure, good.
So basically, what I was confused right now is that we at Darasi are currently supporting the two reactions. One is for the MCP, and we also have reaction for post Dapper PubSub. So I don't see anything that is needed at infrastructure level of within inside Darasi further that is required for completion of this project. So the durable agent, of course, also already provides a support to trigger automatically based on PubSub topics. So I don't see what that smart router reaction and ambient agent requires that is not already existing into these projects.
Yeah, makes sense. So I think you're talking specifically about the Google Summer of Code project, right? Let me just open that website here. Okay, so this is like the ideas list for the projects, right? Let's take a look at the Drasi idea. This is involving a couple of different projects, right? So let's take a look at Dapper. So what I would recommend is you've already started looking at Drasi and Drasi reactions, so that's great. So what I'd recommend is also take a look at the Dapper.io website and try to learn about their concepts as well. So this is like the underlying thing that powers Dapper agents as well, right? So if you look at uh, let's say their concepts, maybe go over just briefly about their high level concepts. So Dapper is basically offering you building blocks to build microservices. For example, it gives you capabilities to do service invocation, publish, subscribe, workflow, actors, etc. And if you look closely at the Drasi for Kubernetes repo, we are also internally using Dapper, right? So today, if you do a Drasi init on top of your existing Kubernetes cluster, if you carefully see the logs, we are also installing Dapper as a prerequisite. So while you're doing experimentation for this project, what I'd recommend is, like, let's say you have spun up a local Kubernetes cluster, let's say a kind or K3D cluster. You can try out Dapper init first, and it'll install Dapper, and then you can do Drasi init, or you can just do Drasi init. And both of those will lead you to basically get Dapper as well as Drasi installed on your Kubernetes cluster. Now, just try to understand these concepts and maybe run through one or two of the examples on Dapper website as well. Maybe try their getting started example. Maybe try these Dapper quick starts of one or two of these, like let's say PubSub or service invocation. So that'll give you a deeper understanding of Dapper project. And then once you're done with that, I'll come to your question as well. I'm just trying to set some context. And then what I'll recommend is just go to the Dapper Agents website and try to understand how to get started with Dapper Agents, try to build the first agent, and try to understand the existing patterns inside the Dapper Agents framework. You have like a bunch of different frameworks here, right? A bunch of different patterns here, like the durable agent that you mentioned. You can also do prompt chaining, etc. So now, once you've gathered all that context, now coming specifically to the reactions. So we have a couple of different reactions here. So in the Drasi platform repo, we have a bunch of different reactions, right? So you have the HTTP reaction, the MCP reaction, the Dapper reactions. For example, inside this, we have a post pub sub one that you mentioned, which effectively means that uh, Drasi queries, whenever they are sending updates of, let's say, added result set or result set got added or a result got removed or updated. So all of those messages will get posted to a PubSub channel, right? And that can be any kind of PubSub which is supported by Dapper. So for that, we have this particular reaction, and you can take a look at the documentation here, how to use that. So for that, we also have the tutorial on our website Drasi.io, and then Drasi for Kubernetes, Drasi for Dapper. So this one, right? inside Drasi for Kubernetes, tutorials, Drasi for Dapper, and this is where the third demo is where we look at the pub sub reaction. So you can try this one out. Once you have done that, that'll give you some information on what this reaction is all about, and also take a look at the sync state store. So now coming to the project itself, right? So that's where the initial seed idea was that so we have agents that exist inside like the Dapper agent framework. You can build different agents either using the durable agent pattern or other patterns. So the one of the key ideas here is the agents today need to do some kind of polling if they want to detect conditions across different let's say different data systems, right? So you want to monitor for conditions changing across different systems. It could be databases, could be Kubernetes cluster, it could be microservices, it could be whatever, right? Now, one way, the existing way today inside Dapper agents is you either need to poll those systems or maybe set some kind of other framework that will basically notify your agents, which are effectively just actors, right? So they are basically built on top of virtual actor pattern. But what Drasi allows you to do is Drasi can basically act as a sensor. So it's constantly monitoring the change feeds from these systems. And then based on the query results, it can trigger different agents on the Dapper side. You could use the post pub sub, and that could be, let's say, the first kind of like the first week or first couple of weeks demo for your GSOC project. But the longer term goal would be to basically allow Drasi to become Drasi to enable ambient agents, right? The so that you don't need to, let's say, have your have your agent run constantly and poll it for different services. Just rely on Drasi to trigger it, right? So that for that, what I would recommend is also look at how the existing MCP reaction works and what are the available options for MCP integration on the Dapper agent side. And based on that, we can start looking at how do we come up with the end-to-end solution that can then enable our example architecture, right? So the goal is like a couple of different things. So first one could be, as you said, basically maybe use the post pub sub to just launch an existing existing Dapper agent. The second one could be to basically build this router reaction use that hosts an embedded MCP server for agents to discover queries at runtime, right? So let's say you have, so the example that you're talking about there, basically what we are doing is we are configuring something statically, right? So we are telling a particular agent that or maybe we are telling Drasi that, hey, this agent exists. And whenever a new change happens, you need to trigger this particular agent with these kind of parameters. So that is more static. What about dynamic, right? So what about a dynamic scenario where you have just Drasi running and you have your queries defined, and maybe you have a new reaction that hosts an embedded MCP server. Now, the agent authors don't need to worry about how Drasi was configured because it's an MCP server. So they just need to add MCP and then the Dapper agents will be able to discover the capabilities, the queries themselves, and subscribe to the capabilities. So that they can start watching whatever new rows are getting added, updated, or deleted. And then based on that, they can take some actions. And then for that, we might also need to make some changes on the Dapper agent side. So we may need to add some extensions on their APIs, maybe some of the Python models, and then add some decorators for the cloud events. So that would be the idea. And we can take a more deeper look at that in a subsequent office hours. So I'll try to host another another instance of these office hours that can be a more deeper dive into that. But as a first step, I would recommend taking a look at the existing uh, documentation for Dapper and Dapper agents and also Drasi, trying out some of the examples, especially looking at the MCP reaction that we already have in Drasi today. But that's not the entirety of it, right? So you could, of course, propose newer forms of MCP reactions. So yeah, that's where the like the seed idea is, and of course, you can modify this idea based on your own findings, propose new ideas, like within that, like how would you build the ambient agent demo, etc. So yeah, that's what the idea is all about. How does that kind of give some of, like, answer some part of your question?
Um, yeah, it does answer some parts of my question. Also, thanks for setting up context for everyone. So also I have tried Drasi for Dapper tutorials, so I am aware of the post uh, the Dapper post pub sub reaction. I have tried that out. Regarding the MCP one, I have skimmed through it, not tried it myself. So the problem that I had with this first statement, that Drasi router reaction, we are essentially trying to combine both features into a single microservice that we are labeling it as a new reaction. That's what I am currently understanding it. So what I was pointing to, that this thing can already be done with multiple reactions, because MCP reaction is also supporting us to basically, it is providing us capability to watch queries and provide results through an MCP server, I think.
Right. Yes. So that's what you need to investigate, right? So uh, maybe try to use the MCP reaction once in a small tutorial. So what I'd recommend is, like, let's say set up a simple Kubernetes cluster maybe on your laptop or wherever. So for that you can use either Kind or K3D. Then just install Drasi on it, and then try to run the MCP reaction with just maybe like a simple source and a simple query, right? So once you have the MCP reaction up and running, um, then you can try to maybe use it using some kind of MCP client. One of the MCP clients is, for example, like Cloud Desktop or one of these CLI tools available today, right? So try to see like what is the pattern, how do the queries get exposed, right? And if you look at the MCP spec, so there's a bunch of different things inside MCP as well, right? So you have MCP tools, or you can also have MCP reactions. You also have like server-side events or maybe even HTTP-based notifications there. So uh, now the question becomes like, how would we model the queries or the capabilities that Drasi has uh, while aligning with the MCP spec for this new reaction that you will build, right? And this new reaction should also be such that the Dapper agents framework is able to discover the capabilities properly. So I think the existing MCP reaction exists, but I am not sure whether the Dapper agents are able to utilize that. So try it out, and I'll also take a look at it and maybe post some more details on the Discord server, or maybe we can also do like another follow-up another follow-up of Drasi office hours for that. And just to
Sure.
answer your question about one more thing about the
Since we get a returns result and then it's done.
sorry, so one more thing that you asked about specifically about the MCP reaction. So another video I'd recommend is this one. So this is like from the one of the podcasts at Microsoft where we described the Drasi system. But in the second half of the podcast, you'll take a look where Daniel from our team has already used the MCP reaction to build a Python-based game, right? So he has built a Python-based game, and I think even that code is available. So you can take a look at how did he use the MCP reaction for that. So, and for that, he also needed to add some of the things in the on the lang chain side. So yeah, you can also investigate that if that interests you.
All right.
Does that make
Thanks. Interesting. I'll try that. I'll try these things out and leave my findings in the Discord server.
yeah, sounds good. We have like a bunch of folks. Any other questions? We still have like about 5 to 6 minutes.
Hello. Uh, I was also in morning meeting and my side is morning, so I am just wake up from. So like I was not that in Drasi, so I come up with same like I might figure out what you are trying to do. So should I share or it might be repeating the what we have written here, or should I?
So your question is
Uh,
specifically about the project here, or
uh, yes, mostly is there. Okay, so like the morning I have time, so I check how Drasi and the Dapper agents like working.
yeah,
So I come up with the theory like in Drasi we are treating it like a nervous system and the agents like a brain.
right,
So if we are like in nervous system. It's not costing that much money, but it keeping the nervous system active. Like if we have Kubernetes and there are many things running. So when we add something new, but it is harmful. So if we have only agents, so it cost like money and anything. It's not easy to maintain them. But Drasi, it is easy to maintain them. So if there is something harmful, Drasi's nervous system react to the MCP and they go to the specific agents. On the dapper side, we have actors, like we have specific actor which can solve this situation. Like so, this is all a working autonomously and ambitiously because it can sense the thing. And we have the organization like we are building an ecosystem in which the everything keep running without even human intervention. Is this is what are we doing? Like I might be wrong, or
Yeah, at a high level, I think you're kind of right. So basically, so the agents don't need to keep polling, right? So LLMs, as you know, are
yes.
so we don't need to basically trigger the agents to start up again
Mm.
and again and burn our tokens. So that's
Yes.
so that Drasi can watch the conditions and then
Mm.
make the ambient capability available to the agents.
Yes.
Can even though they are not running all the time, they can be
Mm.
triggered whenever the relevant changes happen. Now,
Yes.
let's say the agents are going through some tasks that the user has assigned to them. So the user doesn't need to tell the agents explicitly that, hey, there's a Drasi thing running and you need to go to subscribe to this and this query. The agents can then use MCP to discover these
Mm.
things automatically, right? So just like,
Yes.
let's say you're using any kind of AI agents, let's say on your even on your laptop, right? So
Mm.
all of us are using, let's say, different things. Let's say, what is it, Cursor, or let's say even in VS Code, there's GitHub
Mm.
Copilot, or there's like Claude, etc. Right? So all of these agents are kind of like MCP clients, right? So where you
Yes.
can have a bunch of different MCP servers. So for example, you can add Playwright server that allows your agent to control the browser itself, right? So that
Mm.
is one example. So these MCP servers allow different agents to do different things. So one of the things is just making some tool calls. So let me just bring
Mm.
that as well. So so this is the MCP website, right? So if you look at
Yes.
MCP, right? So it basically has different concepts like servers and clients.
Mm.
So clients are basically going to be either some things that we chat with, so like the
Mm.
chat-based agents, like Claude or GitHub Copilot, etc.
Yes.
Then the servers are that give capabilities to these different clients, right? Right. So the servers can have different features. So there could be tools that allow agents to take some actions. They can also be
Yes.
resources, so that these are kind of passive that give the agents some read-only information. And then there's like prompts and
Mm.
based resources. If you look at the spec in more detail, if you click around and find out in the spec, you can
Yes.
also have notifications for resources, right? So let's say when of the resources like when of the list of resources change or the resource themselves change. So the clients can subscribe to notifications on these resources. So that could also be another way for the agents to discover that changes are happening, right? And then
Yes.
how do the agents discover what are the tools or resources or capabilities offered by a particular MCP server? Well, for that, we just add like text-based descriptions, right? And then
Yes.
the MCP server is registered with the MCP client. Whenever the agent is running, if it encounters a question from the user or a task that it's working on, depending on that, it can look at the different servers that are configured, and it can basically figure out which tools or resources it wants to use, right? So that's where like the question arises, like how do we make the MCP reaction the existing one, or you can either use the existing one or you can propose to build a new one so
Okay.
that uh, it becomes more amenable for the Dapper agents to start using Drasi-based MCP server.
Okay. Because Drasi is already reacting it very precisely. What is and where is thing going wrong, or like we know. So how we handle and how we utilize that information with the agents. So this is one of the question, like how we fully utilize this. And do we have any session on specifically on Dapper agents, like Dapper agents? Will we?
Uh, I can try to see, like, let me see, like, if I can find time on that. But
Okay.
I can't promise, but I'll try to see if I can do another
Okay.
session.
Thank you.
But
because
yeah,
it's very interesting. Like we have embedded system, we do not need to tell it. It already maintain the system and on Kubernetes. It's really interesting. So
yeah,
it's really interesting what we can do with this.
yeah, yeah. Yeah, so Dapper Agents is pretty neat. That's also another CNCF project. So if I'll try to do a session if possible. If not, then yeah, I'd recommend just going to their website and trying out the getting started examples. I think that should also be pretty straightforward. Just
Yeah.
and I think these ones are just running inside your local modes, right? So you don't even need Kubernetes for that.
Mm.
So just follow along these things, right? So just copy to the clipboard and then run this on your terminal. I think this should be at least the getting started should be easier, especially if you're comfortable with Python. Just try to walk through this small, like this short amount of code. So that will give you like some feel of how to use the Dapper Agents framework. And then you can, of course, take a look at their other more detailed quick starts. So for example, you can take a look at like their durable agents example, some workflow examples, etc.
Yes. Thank you. I just want to clear if my thinking is correct. Was
Yeah. Yeah, well, we are all very excited at Team Drasi that all of you are interested in the project. And yeah, I'm still open for any other questions you may have. Okay. If not, then yeah, please feel free to post any questions that may arise later onto your Discord on the Discord. I'll try to answer, and maybe even other core maintainers will try to answer. And yeah, we are super excited, as I said, to have all of you join the Drasi project. You're all welcome to take up some good first issues or create contributions there. Even if you are not able to do that, try to follow along the tutorials for Drasi. I know this project is a bit more complicated because it involves different projects together. So it involves both Dapper agents and Drasi. So you need to also gather context about Dapper agents, and Drasi. So that's a bit much. So yeah, even if you just are able to go through the tutorials, gain comprehensive understanding of the project, and then propose your ideas based on that. So that'll also be great.
okay.
Yeah. Yeah. Thank you, Ray. Thank you all for joining. That's all for today. I'll try to post this video for this session and yesterday's session on the Discord, so all of you can take a look. And yeah, thank you for joining.
Thank you for session.
Thank you.